Imagine a world where the very building blocks of reality are a complete mystery. Scientists knew about 63 different elements, but they were just a jumbled list of names, a chaotic mess with no rhyme or reason. It's like having a library where all the books are thrown on the floor in a giant pile. How could you ever hope to understand the story of the universe? Into this scientific chaos, a man was born. His name was Dmitri Mendeleev, and his story begins in 1834. Not in a pristine laboratory, but in the unforgiving landscape of Siberia, Russia. His early life was a trial by fire. His father, a school principal, tragically went blind, forcing his mother to take over a glass factory just to keep their enormous family afloat. Then, when Dmitri was only 13, his father passed away, and to make matters worse, the factory, their only source of income, burned to the ground. But his mother saw something special in her youngest son, a blazing intellect and an unshakable curiosity. She believed in him so fiercely that she embarked on an almost unbelievable journey, traveling 4,000 miles across the vast expanse of Russia with him, determined to get him into a university. Her final words of advice to him were not of comfort, but of command. Refrain from illusions. Insist on work and not on words. This harsh, practical wisdom would become the defining principle of his life. After that grueling journey, Mendeleev finally gained admission to a university in St. Petersburg. He quickly proved himself to be a brilliant, if notoriously temperamental, student. He grew into a professor who was both revered for his genius and feared for his explosive passion. His personal life was often as chaotic as his lectures were enlightening. But underneath it all was a powerful, driving obsession, a need for order. This obsession came to a head when he decided to write a chemistry textbook for his students. He was frustrated by the existing books, which he felt failed to present the elements in a logical way. As he began to write, he was forced to confront the ultimate puzzle. How do you organize the fundamental ingredients of the cosmos? He became consumed by the task. He created a set of index cards, one for each of the 63 known elements. On each card, he meticulously wrote down everything he knew: its atomic weight, its density, its color, how it reacted with other elements. He spent countless hours, days, and weeks shuffling these cards, arranging and rearranging them on his desk, like a high-stakes game of scientific solitaire. He was searching for a hidden pattern, a secret numerical language that he was convinced must connect them all. He'd lay them out by atomic weight, then by chemical family, but nothing quite clicked into place. The full picture remained just out of his grasp, a frustratingly incomplete melody. He worked himself to the point of utter exhaustion, his mind a whirlwind of numbers and properties. And then, one day in February 1869, it happened. After 3 days straight of wrestling with his cards, he finally collapsed at his desk and fell into a deep sleep. It was in this state of exhaustion that one of the most famous eureka moments in the history of science occurred. He later described it himself. In a dream, he said, he saw a table where all the elements fell into place as required. The vision was so clear, so perfect, that he awoke with a start. Without a moment's hesitation, he grabbed a piece of paper and scribbled down the arrangement he had seen in his dream. The result was the first version of the periodic table of elements. On the surface, it was a work of genius classification. He arranged the elements in rows by increasing atomic weight, and when he did, he noticed that their chemical properties repeated in regular, predictable intervals. This allowed him to stack them in columns, creating families of elements that behaved in similar ways. It was a revolutionary way to visualize the building blocks of matter. But the true genius of his table wasn't in what it included. It was in what it left out. You see, as Mendeleev arranged his cards, he found places where the pattern broke. An element that should have been there, according to his system, simply wasn't known to exist. A lesser scientist might have fudged the data, or forced the known elements to fit, or abandoned the idea altogether. But Mendeleev did something incredibly bold. He trusted his pattern more than the complete list of elements known at the time. He left gaps in his table, and he didn't just leave empty spaces. He made a prophecy. He declared that these gaps represented undiscovered elements, and he went on to predict their properties with astonishing detail. He described the atomic weight, the density, and even the color of 3 specific elements he called ecaluminum, ecaboron, and ecasilicon. It was an act of supreme scientific confidence. He was effectively betting his entire reputation, his life's work, on the belief that the universe operated with an underlying, predictable order. For years, the scientific community was skeptical. An ordered table was one thing, but predicting undiscovered matter, it sounded like fantasy. But then, Mendeleev's prophecy began to come true. Within 15 years, scientists, using new techniques, started discovering new elements. First came gallium, discovered in 1875. Its properties were a near-perfect match for Mendeleev's predicted ecoluminum. Then came scandium in 1879, which fit the description of ecoboron. Finally, germanium was discovered in 1886, and it was the spitting image of his ecosilicon. This was the ultimate vindication. Mendeleev's table wasn't just a clever filing system. It was a map to a fundamental law of nature. It proved that the properties of matter were not random, but were governed by a deep, periodic structure. The man who began his life in the harsh wilderness of Siberia, fueled by his mother's unwavering belief, had successfully imposed order on the chaos of the elements. Today, every single student of science begins their journey with the periodic table. It is the foundation of modern chemistry and physics, the enduring legacy of a difficult, passionate man who dared to dream of order and had the courage to predict the unknown. So, here's a thought for you. Which gap in our universe's knowledge do you think needs a modern Mendeleev to fill it today? Let us know your ideas in the comments below. If this story of scientific genius fascinated you, hit that like button, and subscribe for more deep dives into the figures who unlocked the secrets of our world. Thanks for watching.